Hey, it's Ross from RossLukeman.com. Today I want to talk to you about the eternal question for van and RV power systems, which is, should I use breakers or fuses? And the answer is you need both, and it depends on where in the system we're talking about. So what I'd like to do in this video is give you some rules of thumb. For instance, in general, your alternating current power, your high voltage electricity that comes from the power grid, or is just high voltage from your inverter, that's generally going to run through breakers. For your DC power, such as from your batteries, solar, your alternator, that's all DC or direct current power. I tend to use fuses in those cases, but there are exceptions. I'm going to run through and show you what I use. Buckle up, because we're going to run through a lot of components here. But I'm going to tell you what I use in each part of the system and why. I have a little sample diagram here from a system, and I'm just going to break it down piece by piece and tell you what I do today. Now, for my first system, for the battery bank, I did use a massive DC breaker, and this one is 175 amps, but I quit using this because it requires a massive breaker box that it goes in, and it was a very clean setup, but nowadays I find it a little bit overkill. The nice thing about a breaker is it's also a cutoff switch, and instead of using a massive breaker like this, not only is it expensive, but you need a box to put it in. It just takes a lot of room, and so what I like to do now is I will use a fuse on my main battery bank. There's three types that you want to go with, and then I'll use a cutoff switch. So especially with lithium batteries, if the vehicle is in storage, I like to turn that battery switch off, isolate those batteries so they don't get drained with parasitic loads. So by the time you put a fuse in a switch, it's just like having a breaker. And in fact, the breakers are called resettable fuses. That's kind of like the old-timey name was when breakers first came out. They're called resettable fuses. So a lot of the time, the fuses are not going to blow. And so you can have a fuse in there for years and years. You don't need to reset it. And let's talk a little bit about ratings now. For breakers or fuses, it's called overcurrent protection. So in that word, overcurrent, it's over the limit of how much current can go through that line. So by the line, what are we talking about? We're talking about the cable. So a lot of people say, where do I need fuses and breakers in my system? Where do I need overcurrent protection? And you need it on every line, every cable. And the fuse rating for this particular cable, let's point out, the fuse rating protects the cable, and specifically it really protects the plastic insulation that all these cables have, because the system wouldn't work if the cables weren't isolated from each other. We have to have some kind of rubber or plastic on the outside, and that has a limitation on how much heat it can take. For instance, this is a marine cable. The insulation is rated at 105 degrees Celsius. Just hang on, I'm going somewhere with this, but 105 degrees Celsius or 221 degrees Fahrenheit is the rating of this plastic jacket. And so in order for this not to catch on fire, we have to limit the amount of current that runs through it. This cable is rated, this is a 4-aught cable, which means 4 zeros, and it's rated for 445 amps. And so what I tend to do is I'll put a 400 amp fuse. So the fuse or breaker is always less than the carrying capacity of the cable. And by carrying capacity, I mean amperage, and we can also call that ampacity of the cable. So 445 amps, a 400 amp fuse is perfect to protect that. If we go down a couple sizes to the 2-aught cable, this is rated for over 300 amps. I'll put a 300 amp fuse on it. If we do a 1-aught cable, aught means 0, so a 1-aught would be also called 0 gauge. This does over 200 amps, so we would put a 200 amp fuse on it or breaker. But that's the general rule. We're protecting these cables. They're running throughout our power system. They're running inside our walls. If there's a short circuit, which it happens sometimes, we could call it a fault, a ground fault. Basically, positive touches negative and a massive amount of current flows either from the power grid or your batteries, things catch on fire, right? Especially things made out of plastic. They're going to catch on fire first. And so we need those fuses to blow or the breakers to pop and shut everything down. So when it comes to your batteries, you're going to have 3 fuse types. Again, nowadays I'm using the fuses. You're going to have a terminal fuse or MRBF fuse. You're going to have an A&L fuse, or you're going to have a Class T fuse. Now these 3 fuses are rated as main battery fuses by the ABYC. That is the stringent governing body over the marine standards. ABYC is American Boat and Yacht Council, and they want the fuse within 7 inches of the battery bank. When that positive line leaves the battery, within 7 inches you would have your fuse. Now the RV industry is a little less stringent. I think the rule is 12 inches. But in general, when you leave that battery bank, hit that fuse pretty quickly before you go to your cutoff switch. And the reason those are rated as main battery fuses is they have an interrupt current capacity, AIC. Amperage interrupt capacity is what it stands for. So the A&L will stop 6,000 amps coming out of your battery bank. The terminal fuse will stop 10,000 amps, and the Class T will stop 20,000 amps. All of those qualify. The easiest one that will go up to the highest current, the A&L goes up to 750 amps, and these are about $20. Very easy to find. If you want the most serious fuse you can get, it would be a Class T. These are about $50. But in general, the rating, if you get a 400 amp fuse, it needs to be put on a cable that can carry 400 amps. So that's a rule for breakers and fuses that's going to apply throughout your power system. So that's the batteries. Let's move on. Once we come out of the batteries, we hit our fuse, we hit our cutoff switch. Now we need to distribute that DC power from the battery. So the batteries are going to be linked up to your 12-volt fuse block. Your 12-volt fuse block, they're going to be linked up to your alternator charger, your solar charger, your inverter charger, which is shore power. And I think I got them all in there. So we have multiple lines going out from the battery bank. And over the years, I kind of resisted using the links distributor for a little while, but I'm starting to become won over because it's got bus bars, but it's got fuse holders in there as well, built in. And so we can come in here from our battery bank. So we've got our big fuse out here, one of the 3 approved types. And this is going to take mega fuses. Now the interrupt capacity of mega fuses is 2,000 amps. So they're not approved by the ABYC as a main battery fuse, but they're great for your chargers and loads. So solar, alternator, inverter charger, your 12-volt, your line going to your 12-volt fuse block. A mega fuse is great. So you just get the rating again that matches the line. So if you had a 1-aught cable, for instance, it'll do over 200 amps. You'd put a 200 amp fuse on there. So let's talk about what goes in the distributor, because I have kind of a trick. Most of the time for my DC, I'm going to use fuses, but not everything. So let's talk about what would be fused in this links distributor. So first off, you better have shore power in your van or RV, right? You want to plug into the power grid, charge those batteries. I like the Multiplus from Victron, and For a lot of the models of MultiPlus, nowadays they're asking for 2 positive and 2 negative cables running to your battery bank. So of course it's not going to go direct to the batteries, it's going to go to a distribution point, and they ask for a 400 amp fuse. For a lot of the models, you're going to want to check your manual, and that's kind of a secret hack if you want cable sizes and fuse ratings and sometimes fuse types. Check out the manuals, and you'll get a lot of information of what goes in a distribution point and what rating of fuse that you need. So a lot of these are going to say 400 amps of fuses, a 400 amp fuse, and they want 2 1/0 cables. So that would be 2 of these smaller cables, and 400 amps total on the fuse. So I put 2 lines here. Let me set this sucker down. All right, so those 2 cables, I'm going to use this other size just as an example. 2 cables would come in here from the inverter charger. 200 amps per line, we would have 2 200 amp fuses. Mega style would be the type of fuse. 200 amps is the rating. Then we would come down. We need a line to go out to our 12 volt fuse block. Or if you have a 24 or 48 volt battery bank, you would go out to your converter and then it would go to your fuse block. But you need a line to go to that eventually gets to your 12 volt devices. So I would put a 6 gauge on that typically, and 6 gauge can carry more than 100 amps, and I would put a 100 amp fuse there. The last one would be alternator, and if you have multiple chargers, like if Victron or Orion, sometimes people put multiple. Hopefully you can consolidate those lines. If you have one Orion, you would come in here, a 6 gauge cable, they want a 60 amp fuse. And what you may notice is that I've used up all 4 slots of the distributor, and we haven't brought in our solar yet. So conveniently with solar, I don't like to use fuses. So they do have inline solar fuses. It's got the MC4 connectors for solar, and you can just put this in the line. But what do you do if you're putting the vehicle in storage and you don't want solar power coming in? Let's say that you cut off your main battery switch and your batteries are isolated. Well, you can't have solar power coming in off the roof if there's nowhere to send that power. The batteries are isolated from everything else. We need to put a breaker so that we can trip that line and stop the solar power from coming in. And so I like to use this Midnight Solar baby box, and it goes with these MNE PV breakers. So these are 13 millimeter DC breakers. So you got to be really careful on breakers, whether it's AC or DC, because they do work differently. So these are made for DC lines, and Midnight Solar, obviously they make a lot of solar stuff. So these are great to cut off your solar power. And I will put 1 breaker to break the line between the solar and the charge controller, and a 2nd breaker between the charge controller and the rest of the system. And so I'll just hit both of those breakers. It completely shuts down the solar, and what you'll notice is there are a couple of extra bolts on the distributor here on the end, and you can bolt on another distributor, or because we have the solar, it's already got too many parts here. It's already got the overcurrent protection. That's done. So those lines can just come in on these final 2 bolts, and that's where I like to put the solar. Now on the inverter charger, for your shore power, you're going to have the DC lines, right, that connect to your batteries, but you also are going to run the power grid through here, so that's alternating current. And in that case, we're going to use breakers. So we're going to use breakers on the input and the output, and it's going to handle the 120 volt power here in North America. Could be 230 volt if you're outside North America. But for the input power, I like to use a 30 amp breaker. I do a lot of 30 amp systems, and if you have a 50 amp service, you're plugging into a 50 amp receptacle in the US, you would have 50 amp breakers. So you want to match whatever service that you're plugging into. And this is a little Square D box, that's the brand, and it's got a 30 amp QO series breaker. That's the style of breaker. But basically, if I have my shore power inlet on the side of the vehicle, instead of running this cable directly to the inverter charger, I want to make sure if there's a short circuit down line that I have overcurrent protection so this line doesn't catch on fire, because what you're going to do is use a 10 gauge 3 conductor triplex cable, and 10 gauge is generally suited to 30 amps. So I would put that 30 amp breaker on there. If there's a problem in my system, a short circuit, that breaker is going to blow. It's going to cut off all incoming power from the power grid, and that's really helpful. Now, the thing about the inverter charger is going to take that grid power and it's going to send it out into your vehicle on another 10 gauge line if you're running a 30 amp system. And not only do we need to protect all those lines that are inside the walls of our vehicle, but that main 10 gauge from the inverter charger out to our distribution point, we need to protect that line. So going back to the rule, we need to protect all lines. If there's a cable with plastic on it somewhere in the vehicle, it needs to have a breaker or fuse in case there is a problem. We want to prevent those fires. So on the output of the inverter charger, we could do a breaker box for the high voltage lines, alternating current lines. But we also need distribution for our 12 volt DC loads. And so you could have separate units, 12 volt DC fuse block, breaker box, but what we have from the RV industry is we have these boxes that combine both. So this is the PD5000 from Progressive Dynamics. I use this a lot. So it's got 12 volt DC lines. So it's got the same number of slots as this Blue Sea Systems fuse block. So it's got 12 slots for 12 different 12 volt loads. And then it's got a little breaker box over here. And I like to use the Eaton BR series breakers. These are just from Home Depot. I think they're about $7 now. And they're just going to clip and stab into place. And it's got room for 5 breakers. So this is a 30 amp box. So it's suited to 30 amp service. And your 10 gauge line coming from your inverter charger is going to tie into a 30 amp breaker. And then what I'd recommend for your other lines, typically it's going to be 15 amp or 20 amp breakers. A 15 amp breaker would feed a 14 gauge 3 conductor line. A 20 amp breaker would feed a 12 gauge 3 conductor line. And I'm starting to trend towards 20 amp breakers in vans and RVs because unlike a house, it's kind of a small space, and so some people I might have multiple outlets on one breaker, and they may tend to plug in all of their big appliances on one side of the vehicle, and it ends up going on one breaker. And if it's a 15 amp breaker, they're limited to about 1800 watts, and they may need 2200. They may be cooking using electric heating appliances, and it's a little bit more fail-safe to just put in a 20 amp breaker with a 12 gauge 3 conductor cable. So something to think about. And if it is in the kitchen, they now have GFCI breakers. So instead of putting in GFCI outlets, you could just put that in the breaker box and it protects that whole line. And that is something new in the US electrical code. But I do want to show I have a 50 amp box as well. This is from WFCO, and same deal. It's got the fuses for the 12-volt fuses. It's got 15 slots instead of 12. It's going to take ATC fuses, same as the other one. They both take ATC, which is an automotive fuse. So that's your 12-volt side, and then you have your breakers over here for your high voltage side. And this box is made for 50 amp service, so it's actually got a place for a double breaker, which I don't have out here, but you'd have a double breaker that's 50 amps on either side. And in the US, 50 amp service actually has two 120 volt lines coming in. So each of those lines would come into its own breaker, and you could power things that are 240 volts out of those 50 amp breakers, or split off and run things that are 120 volts. But either way, your distribution point for your 12 volt and your 120 volt here in the US could come in the same box. So that is a little bit of a hack there. You don't have to use a separate fuse block and a separate breaker box. You can combine them into one unit. So that is the deal with breakers and fuses. Now, if you want more information on your overall power system, on things like solar, alternator, and shore power, I have a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of those three major charging sources, and it talks about how they each have strengths, but they also have weaknesses as well. And you really need to bring them together in a holistic power strategy, and that's going to make sure that you're covered in any scenario out on the road, so you can enjoy what you're doing out there and you're not going to be worried about running out of power. There's also a discussion about different battery types and the strengths and weaknesses of those. That's going to help you narrow in on which battery type is going to be right for you. And then lastly, there is a really cool diagram that shows essentially your entire system on one page. It's going to show the three major charging sources at the top: solar, shore, and alternator power. And it's going to show how each of those link through the system, come out and charge your batteries, and then get distributed to your end devices such as your microwave and your laptop. For instance, how does the alternator power come through and end up charging your laptop? So it's a really cool diagram that I think you'll find useful. To get your own copy of the Ultimate Van Power Cheat Sheet, all you have to do is click the link below or go to rosslukman.com/vanpower. So I hope that was helpful. It is kind of a nuanced question. Breakers versus fuses. As you can tell, it depends on where in the system you are referring to, but I have given you all of the best practices or the methods that I use these days in each part of these mobile power systems. So I hope that was useful. I appreciate you watching, and I'll catch you in the next video.